In this problem, we're going to talk about the law of cosines, and we're going to use it to then solve this example problem. So first of all, what is the law of cosines? Well, we've all heard of the Pythagorean theorem, a squared plus b squared is c squared. The law of cosines is actually a generalized version of it. So instead of just a squared plus b squared equals c squared, we also have this other term over here. Now the reason is because the Pythagorean theorem assumes that you have a right triangle, a 90-degree angle. And so if you have a 90-degree angle, then if this angle C is 90 degrees, the cosine of 90 degrees is 0, and this whole term drops out, and you're left with what's that special case of the law of cosines, aka the Pythagorean theorem. But what if you didn't have one of the angles being 90 degrees? If all three angles are something other than 90 degrees, well, then there's not really a hypotenuse and a right angle in this. And so we no longer have the special case where a squared plus b squared equals c squared, but rather we can essentially use two sides and an angle to find the third side. And so basically, the way this notation comes is that we usually call the sides lowercase letters, let's say A, B, and C, and their corresponding angles with capital letters. So for instance, if this is A, then the angle opposite from A is capital A. Similarly, the angle opposite from B is capital B, and the angle opposite from C is capital C. And so this formula over here, where A, B, and C, all the lowercase a, b, and c, everything I've circled here are the side lengths, and this capital C over here is the angle. So really, you could use this one angle C along with, these A's and B's to solve for side C. Now, there's nothing specific about A, B, and C over here. In fact, you could also think about this as if you wanted to solve for side B, then essentially b squared is the other two sides, a squared plus c squared, minus 2ac, the other two side lengths here, times the cosine of b. So it's always, the way to use the formula is that the side length on the left-hand side that you're sort of solving for, isolating on one side, is the angle that goes into the cosine over here. So once you have that set up, and again, the other two side lengths that you have are the ones that go here in the rest of it. So let's apply this to a specific problem. So let's say we have this problem where we're given this angle is 40. We're not given these two angles, A or C. And we're given a side length of 10, a side length of 6, and we're missing the side length of b, and the question asks us to solve for b. So using the law of cosine, that's where, again, we want to be flexible with our law of cosine. So rather than just using this version and trying to plug in stuff for the a's and the c's and stuff, we have to recognize that our goal here is to solve for b. So the best version of the law of cosines to use is, in fact, the b squared equals a squared plus c squared minus 2ac times the cosine of b, which is the angle opposite to that b. So the angle opposite to b, aka what we normally would call capital B, is 40 degrees. So this b over here is 40 degrees. And really notice that the order kind of doesn't matter for the other two. The other, like whether we call, this guy C, right? This guy would be lowercase c because it's opposite from angle C. The 6 is side length A because it's opposite from this angle A. But really, it's just a matter of the other two side lengths, 6 and 10. So if we're trying to solve for this b, it's really just that b squared is equal to the other two, which is 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine of the angle corresponding to the missing side, 40 degrees. And now we have this all the way down to something with just numbers and our b squared on the left to solve for. So from here on, we could just plug all this into a calculator. So for instance, 6 squared is 36. I'll just write down one more step here. 636 plus 100 minus and that's just 2 times 6 is 12, times 10, that's 120, times cosine of 40. Now I'm just going to cosine of 40 on my calculator, gives me about 0.766. And now if I were to just plug all this on my calculator, I get 136 minus 120 times the cosine of 40, aka 0.766, and I get about I get about 44.08. So we have b squared is 44.08. And notice that it's tempting to put that as your final answer, but remember, we've only gotten b, so we need to take the square root of both sides. And so to get b by itself, right, it would not be squared. So when we take the square root of both sides, we get that b is about 6.6. So that's how we would apply the law of cosines.